SRN Knowledge Center. I, Faculty of Physics at SRN International School. Today, I will be teaching you about Chapter 9, Work Power Energy of Grade 9. In today's video, we will discuss about some of the topics under this chapter, and the topics are Introduction of Work Done, Unit of Work done against gravity, work done by a force acting obliquely. In this, we will come under subcategories, that is work done when a body moves at an angle to the direction of force, work done when a body moves at right angle to the direction of force, work done when the force acts opposite to the direction of motion. So let's start with the topic. In our daily life, the word work means almost any physical or mental activity, but in physics, it has only one meaning, that is, work is said to be done when a force produces a motion. Let's understand with help of some examples. First, when an engine moves a train along a railway line, it is said to be doing work. Second example, a horse pulling the cart is also doing the work. Third example, a man climbing the stairs of a house is also doing the work in moving himself against the force of gravity. The work done by a force on the body depends on two factors. First, the magnitude of the force. Second, the distance through which the body moves in the direction of force. Therefore, work done in moving a body is equal to product of force exerted on the body and the distance moved by the body in the direction of force. Therefore, the formula becomes work is equals to force into distance moved in the direction of force, that we can write as W is equals to F into S. It should be noted that when a body is moved on the ground by applying a force, then work is done against the friction which opposes the motion of the body. Next topic is unit of work. Work is the product of force and distance. Since unit of force is Newton, denoted by capital N, and that of distance is meter, denoted by small m. So the unit of work is Newton meter, which is written as capital N into small m. This unit of work is called joule. It means that 1 joule is equals to 1 Newton meter. Now, the question is, define 1 joule. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, then the work done is known as 1 joule. The SI unit of work is joule, which is denoted by letter capital J. Work is a scalar quantity. Now, the next topic is work done against gravity. The force of gravity of Earth pulls everything towards the surface of the Earth. So, if we lift a book from a table, we do the work against the force of gravity. It means that when a body is lifted vertically upwards, then force is required to lift the body is equal to its weight. So, whenever work is done against the gravity, the amount of work done is equal to the product of weight of the body and the vertical distance through which the body is lifted. Suppose a body of mass m is lifted vertically upwards through a distance h. In this case, the force required to lift the body will be equal to the weight of the body, that is m into g, where m is the mass and g is the acceleration due to gravity. Work done in lifting a body is equals to the weight of body into vertical distance. So the formula becomes W is equals to m into g into h. Now let's come to the next topic, work done by force acting obliquely. Obliquely means at an angle. So far we have considered only that case of work in which the body moves in the direction of applied force. This, however, is not always so. In many cases, movement of the body is at an angle to the direction of applied force, as you can see in the example. Here, a child pulls a toy car with a string attached to it. The car moves horizontally on the ground, but the force applied by the child is along the string held in his hand, making some angle with the ground. In such cases, we cannot use the formula W is equals to F into S. The formula which is used is W is equals to F into S cos theta, where F is the force applied, theta is the angle between the direction of the force and the direction of motion, and S is the distance moved. Depending upon the above conditions, we can come to an end that work done can be positive if the angle between the force applied and the direction of motion is 0 degree, as the value of cos 0 is 1. Work done can be 0 if the angle between the force applied and the direction of motion is 90 degree, as the value of cos 90 is 0. Work done can be negative if the angle between the force applied and the direction of motion is 180 degree, as the value of cos 180 is minus 1. That's all about work done. I hope you like this video. Please like, share and subscribe our channel. Thank you and have a nice day.